Hi, everyone. Thank you for joining us and welcome to Open Infra Live, the Open Infra Foundation's hour-long interactive show sharing production case studies, open source demos, industry conversations, and the latest updates from the global open infrastructure community. My name is Kristen Barrientos, and I will be your host today. As a reminder, we're streaming live on YouTube, LinkedIn, and I will be sharing your questions. I will also be answering your questions throughout the show. So feel free to drop them in the comment section, and we'll try to answer as many as we can. Before we get started, I wanted to thank all of the Open Infra Foundation members. Their support makes Open Infra Live possible, so thank you so much. Now, let me introduce our guest. Today, we're joined by a panel of Zuul operators, and they have invited two very special guests from Volvo to talk about their deployment and discuss their operations. Please welcome James Blair, Clark Boylan, Jeremy Stanley, Johannes Foufas, and Moise Ahmed. Welcome, everyone, and I'll hand it off to you, James.
Hi, thank you, and welcome. I just wanted to sort of get started today by asking Johannes and Moise, how did you get involved with Zuul?
Yeah, that I think was around 2018. We were working on a ECU in the car, and we had a bit over 100 developers. And we have started to run Jenkins as a CI system, as a continuous integration system, and we really enjoyed integration hell. We stayed up late nights, trying to solve issues that was just merged, and everything stopped, and we had to try to find the breaking thing. So at that time, one of the senior managers just told me and two other persons, you really have to solve this. And I didn't know much about CI at the time. Actually, I was a developer. And we just investigated a lot of things, like what is there? We heard about gating. So we searched the internet, like, are the gating systems available somewhere? And I remember we tried GitLab. We even tried Fabricator. I think at that time it was Facebook's CI system and so forth. But it didn't have built-in, gating. And then we stumbled upon version 2 of Zuul. And we liked, we already used Jenkins, so we were familiar with it. We switched to Gerrit and Git. And then there we go. And I think since that point, that ECU, that computer in the car had a green master. It was working. And we built up these DevOps teams. I think in the beginning we were like 1 or 2, 3 people. And we had to spend time weeding out breaking code, or code that destroyed the project. And we could focus on building up the CI infrastructure. So that's how it started, really.
That's great. That's I think Zuul's that's kind of the banner feature of Zuul, the project gating aspect of it, and the fact that the project's motto is stop merging broken code. So it seems like that's exactly what you did. So that's great.
And we discovered that it's not a magic pill in itself. It's dependent on having good test cases. So at that time, we really sat down. We had days, like we sat down with all the different modules that we had, and which is your critical function? What do you do? And where is your gating integration test? Just to protect the functionality of the code base. But with that, if you have that, then I think it's just it's a simple thing, really. Yeah, I think it's maybe too simple at times, but it really works.
If I can drill down on that actually a little bit, have your developers sort of changed what they do now that they have a gating system? Does it change how they think about testing the software, how they write tests, that sort of thing?
It's a very hard. If we now spin back to or go back in to present time, we have a much larger amount of users. I think I loosely counted maybe up to 1,300 users. So it's very hard to answer this question, but for some people who seem to enjoy Zuul and Zuul, the newer versions that we have with Ansible, it has changed their behavior a bit. Yes, they collaborate in a different way, and they use a lot of the depends on functionality in between themselves, and they're really careful with their tests that they have. I think the issue they have maybe is like when you connect many islands, that they they want others also to gate and have gating tests. So they are like, don't destroy our tests like from external dependencies, more or less. And it's something we are working with a lot. I mean, we have this. We're working with this. I mean, the major part is our core computer that you can read about on internet and YouTube. And in there we have a major part of the developers, and we had I think I talked about this in Berlin 2 years ago, but we have 900, almost 1,000 projects in one tenant, and we are trying now to reduce that amount, for different reasons. It's easier to manage centrally, and for those who handle the integration, and that I think will make it easier to own the gating test together in a way. So, yeah.
Do you see, you mentioned depends on and cross repo dependencies. Do you see that driving greater or better or richer interaction between your software development teams? Is the tool kind of expanding its influence beyond CI and kind of impacting how your developers communicate and work together?
Yeah, in a way, in some teams, I would say, and especially in our own teams. I mean, we have me and Moise. We belong to 2 DevOps teams, and internally, yes, I see that. I mean, I see it's used a lot, and then also when we do fixes to the base jobs we have, for instance, that we serve, then we use depends on a lot, and if you're gonna if they are stuck with something, then use depends on this fix, and they can continue working. So that is really great, actually. I think that's one of the greater things. And also when we develop things, I mean, when we try to increase functionality, introduce new base jobs, for instance, it is fantastic to have the depends on functionality. It's so I see it a lot, but not everyone uses it yet. I think, and we have one tenant. It's called EPF. It's electric propulsion. They have their own tenant. They work with electric drive, electric motors, charging, and I think when they moved to Zuul, they're one of the big things they told us is like, wow, this depends on. This is really great. Yeah.
Great. You mentioned tenants, so I guess the implication then is that you are using Zuul in a multi-tenant fashion. Do you find that useful as far as organizing the work between the different groups, or how does that functionality in Zuul, aid your CI design and deployment?
It helps a lot. I think. I mean, I would like to have more tenants than we do have, but it's really we had some boundary conditions that actually forced us to have one tenant that just blew beyond proportions. I mean, I'm checking like 973 projects. But it has helped to separate. I mean, our electric propulsion tenant, for instance, and that has helped tremendously, and it helps with the speed of Zuul. the smaller tenants are faster. The response time, this event job time, before the Gerrit or when the Gerrit event comes and the job starts. That's what developers really, want to have fast. And the smaller tenants are much faster. Then also, of course, we have one Rust tenant. So they have a small little node on the core computer, and I think they have 10 projects, and they do everything in Rust. And they are pretty much self-sufficient. We they have quite isolated jobs and so forth, and we don't hear much from them. It's just when I think the other day we got something stuck in one of the schedulers, I think, James, or something, yeah. And then we had to do a restart, and then they were happy again, and then so we have six different tenants. We also have one for large-scale autonomous drive simulations. They have their own, because they really they don't interact a lot with the software patches that goes into car. They take that and they build simulations, and then they run really large-scale things. So they have their own tenants. And then, of course, we have the Zuul tenants used by us and the DevOps group. We have a few Zuul admins in electric propulsion in their tenant. That's really nice. They are now, I think, 3 administrators. So they help out with their running, and they're pretty much self-sufficient. So yes, it helps, but I would like to use it more if possible. Yeah.
So you mentioned when you first started using Zuul that you actually were interested enough in the idea of gating that you even changed the code review and revision control systems you were using. I think a lot of people get attached to their workflows, and not a lot of organizations or at least their engineering teams are necessarily willing to consider significant upheaval in their workflows. What was that like for the people who were initially adopting it?
Now, in retrospective, maybe it was a hard experience for some of them, actually. I mean, we came from Subversion at that time. And, I didn't know Git. I was afraid of Git at that time. And, I just read up on it. I thought I have to have courses for developers. So, and other team members were pretty busy with other things. So I just had courses for all of them, and I tried to study up as much as I could on Git, and even the more extreme cases. And I started to use Gerrit and Markdown files, GitLS, to create Git and Gerrit like guide for our developers to make a. But I remember when I started to reading about Git, Linus saying that he deliberately called use the same names for different things, just to, I don't know, it was a kind of hint to Subversion at that time. So it was hard for some of us. But then after a while, I think, more and more people just accepted it, and people actually started to appreciate that shift to Git, and especially Gerrit. I mean, I must say, I really, really enjoyed Gerrit as a code review tool. I thought it was just it was simple, not so fancy looking, but very, very nice to review in. It took a while, for sure. Yeah, it took a while, but and now I think it's not a question anymore. I mean, I think they made a decision, even like Git Gerrit, that's what we're gonna use. Yeah.
Do you use any other code review systems or just Gerrit?
We use a little bit of GitLab in Zuul. Mm-hmm. Actually, the integration project of our core computer is in GitLab still. So yeah, we have that interaction, and we had a few times when team members, had updates in our Zuul job configurations, and they use depends on in GitLab. And I didn't know even if will this work. I checked the documentation. I think I even pinged you, James. I will this work? Because I couldn't find anything in documentation at that time. But you it did work. So we do have that. Yeah.
I think that's probably one of the real killer features of Zuul at present that really no other CI/CD systems implement is cross-platform, cross-code review system change management and control.
Yeah, especially since the platforms themselves are interested in seeing, the CI system as both a feature and a vendor lock-in opportunity. So, but with Zuul, we're pretty agnostic about that. So we want to test your code no matter where it's hosted. So that's interesting that you're in the situation where you've got some teams on Garrett and some on GitLab, and I honestly think that's pretty common. In larger organizations, every team sort of they have their tools that they're comfortable with, and I think it's neat to be able to bridge that gap and actually get integration work done.
Yeah, and those other organizations, they typically wind up siloed with the people who are using one code review platform stuck on one CI/CD system and everybody on another, and there's not an opportunity for crosstalk, or they've invested lots and lots of their own engineering time on building some sort of an integration bridge between them. So the fact that Zuul can supply that, I think, is really cool.
Let's talk about some more technical stuff here. Can you tell us how you deploy Zuul?
Yes. So we are basically using Helm charts. So a little bit of background, we have deployed Zuul on Kubernetes cluster, which is hosted on AWS. So there's a service by the name of EKS, which we use on AWS. And that cluster hosts our Zuul pods, and we deploy those pods through Helm charts, which basically we have in one of the repos. Now we have 3 clusters, and we're basically following a very common pattern here, where we have one common file for all the 3 environments, and we have 3 different files for all the 3 different environments. So let's say if we want to override some settings, let's say for the dev environment or the stage environment or the prod environment. So we can basically write those settings, those configurations inside those respective files. And let's say if there is some common configuration, then we can write that in that common file. So it's very common practice to do that with Helm charts, and we are following that pattern as well. Other than that, we have a pipeline for it. So our Zuul jobs themselves are responsible for deploying or updating and managing our Zuul pods. And basically how we are doing that, in Kubernetes, we have a feature by the name of rolling updates. So when we apply, or let's say run Helm upgrade command, basically what's happening in the background is that it's taking down one pod at a time. So I would say we don't have complete downtime. I would say we have partial downtime, where one pod is brought down and another pod in its replacement is brought back up. So that's in short sense is how we deploy Zuul on our Kubernetes cluster. And we have different, because we as Foufas was talking about gating pipeline, we have different stages as well, where we have different checks in the check pipeline, we have different checks in the gating pipeline. And then finally, when all of our checks have passed, we deploy the Zuul Helm charts in the deploy pipeline. So that is how we deploy our Zuul infrastructure on our clusters.
Can you talk a little bit about the scale and the components? So you talked about your deployment and how you do rolling deployments. Can you share how many schedulers and other Zuul components you use?
Yeah, so right now, at least for the production, We have 6 schedulers, 10 executors, and I think the web pods are 6 as well. I think this is the count that we have right now. Other than that, the Zookeeper pods count is 3 right now for production. But this count is not the same in the other environments. Like, for example, in the staging environment, our number of executors is 1. We have 1 scheduler as well. We have 1 Zookeeper, and we have 1 web pod. So, and it's pretty much the same in the dev environment as well.
I'd actually like to pause here for just a second. We have a question from the audience. And the question is Zuul meant to compete with Git, or is it a supplement to Git? So I don't know. Jeremy, do you want to start with that and sort of talk about Zuul's relationship with Git?
Yeah, so probably the most important thing to understand is that Git is fundamental to and underpins basically everything Zuul does. All of the references that Zuul works on are basically Git, and the things that trigger it for the most part are events from revision control systems that are or code review systems that are managing changes or pull requests or other kinds of merge requests, etc., in Git hosting and code review systems. So that's Zuul basically, not only does it work well with Git, it effectively requires the use of Git for its functionality. And a lot of the relationships that it builds are effectively Git relationships between different sorts of units of work in those code review and revision control systems.
Yeah, and just to add, so you'll find that I think a lot of Zuul users are pairing Zuul up with a code review system like Gerrit or GitLab have been mentioned, but also GitHub. And the idea is that it's Zuul is consuming Git activity from those sources and then driving its continuous integration and deployment using the events, the activity that happens within those code review systems.
Yeah, and the idea with Zuul as a gating system, project gating system, is that it is effectively in control of when commits do eventually merge to branches within your Git repositories, whatever platform it's integrating with.
So Moise, I have some more questions about your deployment.
Yeah.
So how do you handle, I guess, when do you decide to upgrade Zuul versions, and how do you handle version changes and things like that, and how frequently do you upgrade?
Well, when a latest version is released, for example, right now we are on 8.3.1, and we are basically 2 versions below. So we have to upgrade to the latest versions. Mostly, we try to upgrade to the latest version, but sometimes we get stuck in other things as well. So, but definitely we try to be up to date as well. So the whole procedure for it is that we basically test the new version in dev environment and then the staging environment. The dev environment is not an exact replica of the production, but however, we have another environment by the name of staging, which is the exact replica of the production environment. So the staging environment basically ensures that the version that we are testing, is that version correct or not? And we try to deploy certain jobs on those in 2 environments, the dev and the staging as well, just to test whether those jobs are working fine as well. So that is our process for testing whether the new images are working or not. Yeah.
We also very careful. I mean, it depends on also what the upgrade is, because I'm usually the person who's like, oh, whoa, like, wait now. Because we are afraid of downtime basically. So yeah, we would like just to update continuously. But yeah, we're a bit careful, and maybe it's my fault. I'm blocking.
Yeah, but the good thing is that we have partial downtime. We don't have complete downtime. So let's say if something goes wrong in the production, for example, let's say. So the rolling update strategy that I was talking about, that will only take down one pod. It will, if there's an error, then it will not bring down the entire separate pods. So let's say if we have 10 pods, it will only bring down the one of the pods. The remaining 9 will remain the same. So that's a good thing for us.
Yeah.
For the dev and staging environments, you mentioned that you do run CI jobs through there. Are you doing
Yes.
like, is that happening transparently to the users, and you're comparing results between production and staging? Or I guess I'm curious to know how you're choosing which things go into that environment, into the pre-production environments as kind of your canary workloads.
I would say that the jobs that run in production do not run in those two environments, the staging and the dev. So in the dev and the staging, for now, we have you could say test jobs, the result of which we cannot compare with the results of the jobs on the production. But in the future, we are looking to do the same. We want to run some jobs that we can compare between the two environments, or in this case, the 3 environments.
Do you have separate code review servers in that environment? Like, do you have a dev Garrett and a
Yes.
staging Garrett? Okay, so you can
Yes.
you can test all the interactions without bothering your developers by leaving fake comments on their real changes.
Yes, we do have separate Garretts in all the 3 environments. Yes,
Yeah.
Which are obviously shared, because some of the repos of some Garretts might be on one environment, and some of the repos on particular Garretts might be on other environments as well.
I want to switch hats for a minute and maybe actually just talk a little bit about OpenDev's deployment, since Johannes mentioned that he'd like to deploy continuously one day. OpenDev is where we host the development of Zuul itself. Zuul is, of course, open source software. And so Zuul's own Zuul is in OpenDev. And we sort of, we do run that almost continuously deployed. Basically, what happens is once a week around Friday evening somewhere in the world, we start a complete redeployment of Zuul. So just like Moise was saying, it's a rolling deployment. So we restart one component at a time, and that happens. It's whatever the state of the Git tree is at that point in time on that Friday. Is what gets deployed. So we're getting close to continuous deployment. It's sort of a weekly automatic thing, and we've talked about maybe even doing a continuous rolling restart. I think one of the things about upgrading Zuul is that frequently jobs take a long time, and one of the components of Zuul is a job executor. And so if you're restarting this component, you have to wait for all the jobs to finish. And so if you do that one at a time, it can be a pretty long process. So that's kind of one of the challenges that we're looking at in making OpenDev continuously deployed. But I think the reason why I brought all this up is to maybe share a little bit of the positives and negatives about this approach that we have in OpenDev. The positive, of course, is that we get new features fairly quickly, and it happens so often that upgrading is generally a non-event. Like there's no planning that goes into it. There's no concern about what, is this safe or not? Because nobody's making that decision. It's all done by computers automatically. And so that is nice. The downside, of course, is that we have to be constantly on top of any release notes that are saying things like, here's a deprecation Here's something you need to change. Here's something you need to do as part of the upgrade, that sort of thing. Because there's a constant stream of those coming, and we're not batching that up. Zuul's testing of itself is fairly complete. We have a lot of, I think, ridiculously realistic tests in our unit tests for to try to avoid regressions. And so generally speaking, if a change merges, we're confident enough to deploy it. But we're only human writing and reviewing that code. And so occasionally something slips through, and so we have to be prepared that anytime one of these automatic upgrades happens, that we might have to downgrade or do something else to fix it. So it's definitely an approach that I think people can consider. It's doable, and like I said, people, there's at least one instance that's doing that. But also, when you have the entire production of a company on the line, I would understand that maybe the inputs to that equation are different than the an open source development community, where in general we kind of expect, in the rare instances where something goes wrong, people still have their own resources to get their own work done, and they're not completely relying on upstream for everything.
And also go ahead.
No, go ahead.
I was just going to say, from OpenDev's perspective, one of the things that really enabled us to switch to that constant or near constant upgrading model was when Zuul finally dropped its last single points of failure. So we're now able to do rolling upgrades with zero downtime, complete data persistence from the old version to the new version. Old and new versions of the different components are running side by side as upgrades are happening. Redundant copies of the services are being temporarily taken offline, updated, and then brought back into the cluster, and our users don't notice. Unless there is a regression that has slipped through testing somehow, for the most part, our users don't even realize that Zuul is being upgraded on a weekly basis automatically.
And the good news for everyone else is that there's at least one installation out there that's fairly close to the tip of trunk, and so you can feel pretty confident that when you do get to the point where you're comfortable doing an upgrade, someone else has gone through the process before you, and it seems to work for them, or at least if it didn't, the issues with it should have been addressed by the point that you get there.
I really appreciate that you are on Tipper Master in the project. I mean, it gives us a bit of confidence, and as you say, we're at times a bit nervous. We don't want to interfere. If there is a slightest little chance of downtime, we don't want to stress developers who are really working a lot and have deadlines and so forth. So yeah.
If we can jump in here, there was another question that came in from the audience, and they were wondering what the Zuul v2, which was Jenkins-based, to Zuul v3, which became Ansible-based migration, looked for you. How did that go for you? How did you tackle that shift? Because it is a fairly sizable chunk of work to be able to make that jump between Zuul versions.
Yeah, that was we were a bit hesitant doing this upgrade, and I think we took us a long time to do it, and but we really needed the we as the car ecosystem developed, and we had more dependencies and more teams. I mean, we started small scale, but now it's more than 10 times more. And we saw early that things will depend on each other. There will be a lot of dependencies here between different teams. So we really need this functionality of, that users can freely depend on each other's development and still have the gating principle. because we thought, the gating principle is like actually what kept us alive, and increased our development speed. Actually, that's what it did in like practical management terms. So we saw that with these, putting a lot of teams together from the whole company, and they will, have dependencies on each other because of how cars develop. They're like they're like Zuul infrastructures on wheels. They're like they're evolving a lot, from what they used to be. So we that was the reason we did it, but it was very difficult for us. Not everyone was familiar with Ansible, for instance. So that was. But then I think we appreciate the inheritance of base jobs. That possibility. It's something I think that we will try to focus more on our side, to have more control of the base jobs, like defined in one place. I mean, now we offer base jobs to most developers, but they are variations, and everyone can define their own, and it's that I think went a bit. We need to address that, and we need to have like a library or a separate repository where here are the job definitions. We need, but we grew organically, and we were a bit like a garage movement in the beginning. So we, and we worked a lot, and we didn't have we weren't many people. So, we just had to fix things, get it up. And so, but now we clearly see, that we need to arrange that. But the inheritance and the use of base jobs is extremely powerful when you have a large developer community, and you need to upgrade something, you can upgrade it in one place. That's like fantastic, actually.
Did you do a migration from V2 to V3 all at once? Like, was there this is the day that everyone's cutting over, or did you have multiple Zuul instances and users would move themselves as they were ready? And because I think we've seen both approaches used by different organizations.
I mean, for our, let's say, our master tracks, we just cut. But we had to keep, we did deliver. I mean, during the years we used version 2, we did deliver things in production, and we need to keep those up. There are in our industry there are legal requirements. You have to be able to update for a very long time. So we still have those those old systems. So they need to live for quite a long, but not for like master development of our new projects, no. And when I think of it, there's of course, when we grew in scale, we do benefit from that we have multiple schedulers and we don't have this single point of failure. In the beginning, everything was fine, but when we pushed everything into one tenant for different reasons, a bit uncontrolled. We really appreciate the possibility of scaling the system, and of course the rolling updates. Yeah. Did I miss anything, Moise, or no? Maybe not.
No, that's fine. Yeah. I think you have covered everything.
I'll mention that on the OpenDev side, we host a Zuul that is Zuul, as Jim mentioned earlier, and we had to go through the same transition from V2 to V3. So there is, I think that one of the very first blog posts on the Zuul website discusses how the evolution of Zuul happened and how OpenDev Zuul, which hosts Zuul, went through this transition as well, which is may also be interesting to read through if you have more interest in the topic of the V2 to V3 migration.
Yeah. And sort of one of the topics that you just touched on is and was highlighted in the comments is the control between the sort of distribution of control between your sort of central CI teams and your developer teams, right? And it sounds like you want to change that a little bit. It sounds like maybe you've got a little bit of Wild West going on with the team sort of doing whatever, and maybe now you can distill some what they're doing and centralize some of it to kind of standardize, maybe share best practices, that sort of thing. And I think that's one of the when I talk about Zuul, I talk about how that this is like a control slider that you can set anywhere along a scale. So you can completely wash your hands of this and let developers do whatever they want. They can you can give them full control to write their own jobs from scratch. On the other end of the spectrum, you could have a central CI team write all of the jobs and not give developers any choice about whether they're even run or not. Probably both of those are not great ideas. And probably the Goldilocks zone in the middle, where maybe you kind of come up with, here's what we should be doing, here's the best way to go about doing it, here's some foundational jobs that you can build on if you need to add to that. And so I think with Zuul you can set that anywhere you need it. And so that's interesting to hear that as time goes on, you're taking lessons from what the developers are doing and sort of distilling them down and making things more standardized.
Yeah, and I think it's freedom, as you say, freedom is good, right? But the result of it, if you scale, is support also. I mean, it's an issue for our teams to be able to support. I mean, we're as I said, 17 people in our teams, and then we have other teams with 3 or 4, and to handle that massive amount of support, like, oh, the base job doesn't work, or I inherited the base job and I did, so it's an equilibrium, and I think we need to adjust it a bit to be more efficient, also as a team, considering everyone, I think it's important to try to find this balance, and we will definitely, we have ongoing planned work to address this a bit. Yep.
We've talked a bit about code review systems and that side of the house. Can you tell us a little bit about the test node resources that you use? What do you run your tests on? Do you use cloud providers? And you're developing systems for cars, as you know. Do you have real hardware that you're testing on? So basically, what are you running your tests on, and how do you integrate that with Zuul?
I think most of our tests are run on AWS nodes. I would say most of the cloud stuff that we run, it's mostly on AWS. 80% I would say on AWS and 20% on Azure. So these are the two most famous cloud platform providers that we use. Other than that, we do have some static machines on AWS as well, and in the basement as well. We have hardware machines as well, bare metal machines that we use, but they are very limited in number. Mostly nowadays we use cloud machines.
Yeah, so we do have not many, but we do have what's it called in the industry, hardware in the loop setups. So there we connect to a bare metal machine who is in turn controlling the ECUs of the car stacked up in a rack or something. And we have some of the parts of the code go through it before it's released in Zuul. And it's actually performing quite a lot of complex things like closed loop feedback of radars and all these things. But it's it's not as Moise said, it's a much smaller scale. So if you compare it to, I think we peak around 9,000, 10,000 jobs each 24 hours. That's our like peak job. And I mean, we have a small percentage of bare metal and these hardware in the loops things. So, but we try to. So that's one of the issues we have is to bring the massive amount of jobs and patch sets that we run on EC2 machines in AWS, for instance. Just basic unit tests, so G tests, unit tests, and linters and all this, and bridge that to verifying a system, like a functioning system in a much more complex setup. And there we have started to run ARM-based nodes, which have we got an AMI from the one of the OS suppliers that we use, and they provided us with an AMI, so we can run the same architecture as we have on one or the main computer in the car. And we can run the same operating system, and then we are trying to bridge, the very limited capacity of these complex systems with the, I shouldn't say infinite, but yeah, I mean, we don't hit any limits yet in our cloud usage. So that's something we try to address, and it's not an easy equation, but we see that. Yeah, when these new things that turn up in the cloud, that the cloud or that the computer architecture that we have can be supported there, that's tremendously helpful. And we see that we can actually, bridge the x86 Linux environment towards the target environment that is something, ARM-based and completely different. Yeah, very, very interesting.
So you call them racks, not garages? But more seriously, though, it sounds like you have a really diverse set of test resources, cloud resources in different clouds and bare metal, and you've also got different hardware architectures that you're dealing with. Have you found that Zuul's use of Ansible, helps you communicate and work with all of those together? Does having that like a tool that is kind of agnostic to what it's talking to make your life simpler? Or yeah, I see.
Yeah, yes, it does. In fact, we were just recently talking about the cloud providers. We have actually started running jobs on pods as well. So Ansible helps us with that as well. We can use the Ansible script to communicate not only with through cloud platform providers, we can also use the same tool to communicate with pods as well. So we are actually running some jobs on pods as well, Kubernetes pods, and that's one of our future goals as well. We are looking to bring down our AWS and Azure cost by running most of the jobs on pod. So that is our future goal that we are targeting.
Do you you mentioned that you're using AWS and Azure. Are you using them both for different feature sets, or are you sort of trying to get redundancy by having multiple clouds?
It's partially to do with redundancy. So let's say if there is something wrong with AWS, then we can deploy the same jobs on Azure. But mostly, in most of the cases, what we're looking for is, because it really depends upon the nature of the job. And let's say if the job is communicating with something that is deployed on AWS, then our priority is to deploy that job in AWS. So let's say we have multiple Artifactories. One of the Artifactory is on AWS. So let's say if we have a job which is looking to download a huge chunk of data from that Artifactory which is on AWS, then we would look to deploy that job on AWS. But in other cases, if let's say there is some resources which are on Azure and our job is trying to communicate with those resources, then our priority would be, in this case, to deploy that job on Azure. And again, it is to do with redundancy as well. We have had AWS outages. So in certain cases, we did have to shift to Azure. So again, it's to do with redundancy as well.
So you're running jobs, potentially the same jobs in some cases, in multiple providers. I know we do a ton of that in OpenDev. We've got like half a dozen different cloud providers, multiple regions, and so we've noticed that it can be hard to achieve consistency. One of the things that we have done to help that is to build consistent images and deploy the same images into all of those providers. Do you take advantage of that functionality in Nodepool yourselves?
Yes, we do. So we have a pipeline for that as well, which builds the images for both AWS and Azure. So again, our base image is built by the CI images, which is another repo that we use. And then on top of that, we basically build upon that base image to create specialized images for special jobs. So that is what we are doing right now. And we do that for AWS and for Azure as well.
And believe it or not, we actually have Windows images too.
Yep.
Yeah. So we are trying to get rid of Windows images because it's difficult. A lot of our problems has been, connecting Zuul to Windows nodes, especially when they were bare metal. That was like I think we almost rid of our bare metal Windows servers at least. And we have always tried to not use them, but some of these systems are traditionally developed for Windows. I mean, especially the garage, as Clark's saying, the garage stuff. Some of those frameworks and so are still on Windows, believe it or not. But so we sometimes need we still need our Windows images too.
So it sounded like maybe you're not using Nodepool Builder to build these images, because you said you build them in a pipeline. You're actually using Zuul to build the images, right?
Yes, we're actually using Zuul to build the images. Yes.
Okay. Yeah. So I think that's I feel like you're maybe a little bit ahead of the curve on this, because I actually I have a development specification for Zuul that I've started working on, and hopefully we'll be making more progress on it soon, to actually move quite a lot of the Nodepool image building into Zuul itself. So sort of what you're doing now, where you have jobs that build the images, and it's kind of interesting because we've in the Zuul project, we've gone through a lot of we've evolved quite a bit from we started by doing exactly that. We built images in Jenkins and uploaded them to clouds, and then we found that we actually needed a daemon running all of the time to actually make this reliable enough across all of the different clouds that we did. So we developed the Nodepool Builder to do that. But then we found that is, how should I say this? It makes the image building process somewhat inaccessible for users. So if you're hiding it away on this server, it's harder for people to see the build logs and to debug issues and things like that. So the next step is to try to bridge that gap by doing the image builds in Zuul, and then also having Zuul responsible for doing that upload. So kind of keep the background daemon aspect of it for uploads, but move the image building into the foreground for user accessibility.
Yeah, the logs will definitely help, because the user will have more visibility of whether something went wrong, and he could basically debug the issue. So that's good then.
Earlier you mentioned, or you hinted at redundancy and outages, and I'm curious to know, where have you found the operational challenges of running Azul? Is Is it in keeping the service up with high uptime? Is it the upgrades? Is it dealing with the jobs? Where do you find the struggles in operating a Zuul installation?
I think Kubernetes makes it really easy to manage Zuul infrastructure. Like I discussed, rolling updates is one of the features that it provides. So we are good on the redundancy side. And the Helm charts make it really easy to upgrade and manage Zuul stuff. So we are good from that side, I would say.
But I think a few of the struggles we had, because we have two cloud providers, we sometimes have congestions in the communication and the network traffic between. And that has caused, that we have got corrupted executors and because they just couldn't communicate as they should internally. And then we had to debug and, try to, and then that's the struggle, I would say. that
I would describe another scenario that we encounter where, let's say, if one of the PVs, which is a volume on AWS, let's say that's in one of the zones, and let's say Kubernetes has deployed the pod in, let's say, another AZ availability zone. So our pod in that case cannot communicate with the PV or the volume that is inside another zone. So that's an issue that we have encountered. So in this case, what we have to do is we have to recreate that PV in another zone, and so that the pod and the PV are in the same zone. So that is one of the problems that we have encountered. The solution to this, we have also discussed this, that the solution can be to use EFS volumes instead of EBS volumes, which are both on AWS, because EFS is multi-AZ supported, so that will sort of fix the issue. But again, we are looking to cut our cost down. So EFS is 3 times more expensive than EBS. That's what I have noticed. So it's more about balancing between the cost and performance, whether we want redundancy in this case or whether we want to lower the cost. And I would say it's not too much for us, but sometimes we have to manually go in and delete the PV so that it is recreated in the same zone. I guess that's the issue that we have noticed quite often now. And I think there are other issues as well that we have encountered previously. Like, for example, if the I/O of the disk of executors that is attached to the executors, that's not enough, then we have to manually upgrade the disk as well, which in Kubernetes is not a very easy solution, because there are some attributes that you cannot just change. So you have to make those pods orphan, then recreate those executors, and then move them manually one by one. So that's because there are some things, like, for example, I have mentioned the disk size, that's has to be done manually. But there are other fields as well that can be done through Helm charts as well. Like, for example, if I want to add affinity or anti-affinity to some of the pods, that I can do that through Helm charts as well. But for, let's say, something as like changing the disk size, that thing has to be done manually. So that's what we have encountered in the past.
Well, I think we're about out of time, and that seems like maybe a good place to stop. Yeah, I don't know if Johannes or Moise, you have any last words you'd like to share?
Not really. I mean, thank you very much. It's been really nice talking to you. So yeah, thank you for inviting us.
It's been great talking to you and hearing about your Zuul setup.
Yeah.
Awesome.
Thank you for having us.
Thank you.
Thanks.
Yes, like James said, we're almost out of time. So I want to thank everybody for coming today, and I appreciate y'all joining us. And thank you to the audience for asking some really great questions during the show. A big thank you again to the Open Infra Foundation members for making the show possible. And I just want to mention, join us again for our next Open Infra Live on September 21st. For this episode, our guest will be Thailand's largest OpenStack public cloud provider, which is Nipa Cloud. So if you have any ideas for a future episode, let us know and submit your ideas at ideas.openinfra.live, and maybe we'll see you on a future show. Thanks again for today's guest for joining us, and we'll see you all on September 21st for the next Open Infra Live. Thanks. Bye.